What they have found in space revolutionizes and alerts science. In the depths of the cosmos and space, far from the reach of the human every day, lies a spectacle that defies ordinary comprehension, revealing once again the vastness and wonder of the universe in which we reside. This spectacle, although at first glance it could be mistaken for a piece of abstract art because of its chromatic richness and dynamic composition, is in reality a window into the heart of our own galaxy, the Milky Way. This discovery in space, the fruit of the dedication and curiosity of a group of American astrophysicists, takes us beyond the limits of our solar system into a realm barely imagined. In a scientific odyssey that unveils the secrets of the universe, these scientists have stumbled upon an amazing congregation of structures in the core of the Milky Way. Magnetic filaments suspended in the cosmic void were known to exist. However, recent research has uncovered a new population of these structures, revealing their orientation toward the galactic bulge. What distinguishes these new findings from the structures previously identified by Farhad Yousefzadeh, an astrophysicist at Northwestern University in the 1980s, is their arrangement and size. Whereas the old ones were arranged vertically, like giant celestial stalactites hanging near Sagittarius A*, the supermassive black hole at the center of our galaxy, the newly discovered filaments stretch horizontally, spanning space like the spokes of a bicycle, emanating from the galactic center itself. These new components, though shorter, present a panorama in space that evokes the dots and dashes of Morse code, drawing a stellar enigma around one side of Sagittarius A*. Yousefzadeh's team was faced with a startling discovery, a new population of structures pointing toward the galaxy's central abyss, which, in the words of Northwestern University, represented a moment of scientific wonder and revelation. The mystery in the space of our Milky Way. The surprise in our Milky Way galaxy was great when Yousefzadeh, at the head of the study, contemplated these formations for the first time. The meticulousness of their scientific work allowed them to establish the authenticity of their discovery, revealing that these formations were not random, but seemed to be intrinsically linked to the dynamics of the central black hole. This breakthrough not only adds a new chapter in space to the study of the cosmos, but also promises to deepen our understanding of the black hole's rotation and the orientation of its accretion disk, providing unsuspected order within the complexity of the galactic core. The center of our Milky Way galaxy in space, located about 25,000 light-years from Earth, has been the subject of Yousefzadeh's study for 4 decades. After years of investigating vertical filaments, the discovery of their horizontal counterparts, dating back approximately 6 million years, marked a milestone in his career. It was a surprise to suddenly find a new population of structures that seemed to point in the direction of the black hole, Yousefzadeh admitted. I was actually stunned when I saw them. We had to do a lot of work to establish that we weren't fooling ourselves, and we discovered that these filaments are not random but appear to be tied to the outflow of our black hole. By studying them, we could learn more about the spin of the black hole and the orientation of the accretion disk. It's satisfying to find order in the midst of a chaotic field in the core of our galaxy. The new and old filaments in our Milky Way in space share the characteristic of being one-dimensional and visible by radio waves, related to events occurring in the galactic core. However, they differ in orientation, size, and nature. The vertical filaments, which can extend up to 150 light-years, contrast with the horizontal ones, which are only 5 to 10 light-years long. The former stand perpendicular to the galactic plane, while the latter are aligned parallel, pointing toward the galactic nucleus. The attribution of these discoveries to advanced radio astronomy technologies in space, in particular the Meerkat telescope at the South African Radio Astronomy Observatory, underscores the impact of technological innovation in space exploration.